Hello and welcome back. Today it's a lazy Saturday, so I'm just gonna do a lot of little things. The main thing is that I'm going to replace my power meter. I have right there this analog meter with this little power meter, and I just wanted to have something more professional, and so I bought that. I had some points left from Banggood, and so I bought this from DCUU. It's the PM9901, and I think it goes to up to 600 volts and 20 amps, so that is perfect for to use here. And it should fit exactly, so let's see how that works. Yes, and I have a lot of things I still need to clean up. I have here this power meter efficiency meter, so you can measure from your power supply the efficiency by measuring the AC part and measuring the DC part, and that looks a little bit like a Back to the Future panel. Just switching it on is already cool to have it. I don't know if you can see it here. And I'm still charging my microscope. It's just finished, so I can put that also away. And these little RF testers I have here, turned out that one was actually working, so I tried to find the best cover or the less damaged cover, and then the rest can go to my parts. And then I have one that is working, and we saw there was this little crystal oscillator inside. So maybe I can even once try to make external reference. This time it was 26 megahertz, if I understand correctly. Yeah, it was in the bottom, so we can't see. So that could also be a future project, but as you can see, it is damage here. But this is the biggest damage, and I think this is the least damage. So I think I will steal this cover. The color is more or less the same. It's better than a big hole. So just easy things. So let's see what I have on the table here. I have this little RF. It's a high impedance RF probe. And I think this is from eBay, but I will probably also find it on the AliExpress. And it is nicely made, so we are going to play with it. It does need a ground wire. It is not always clear, but it's said in the description. And then you should be able to probe on your frequency counter, probe in a circuit without it actually changes, because it's super high impedance, probably done with a FET. So that is nice to try once. This is just some precision resistors. We also need to play with that. I think this is this AD585, which was not from Analog Devices, but it was just a stacked precision diodes or current source thingies. Well, that was not a huge success, but I will build it in a casing. And oh yeah, this thing I still need to test. This is the LM399. I have here the manual and with the jumpers I need to do, so that will still come. This is some calibrations what I have here. Oh, this is from the Back to the Future. I will scan that and put it in PDF. Maybe I can put it for download also for you guys. And well, let me first clear the disk. Well, I think I had this second one that was also for RX and TX, and I just want to check again because I think the transmit mode was not working. But let's have a quick look. But the receive mode might be. But let me put it in transmit mode. Yes, it does say it's 0.5 watts. which is correct, but it doesn't say the frequency. Okay, the receive mode maybe is working. Push long one. Yes. I can just type it in directly from the 027-205, I think. 0, yeah. Same, minus 120 dB. So the receive mode is working, it's just that the transmit mode is not working. And it does detect the power, but it does not detect the frequency. Long push 1, now it's again in. Yeah, it does say 0.5 watts. So that power meter, well, first of all, it was from Banggood and they ship it properly this time, but not even with the back around it. It was just properly shipped because the manufacturer just packs it nicely. Because you can see this is just a naked box, but no problems there. I'm just happy. Hopefully it arrived good. I already did open it. There is a Chinese manual here. I found on their website the same Chinese PDF, and I found some service to automatically translate that to English, so I did. I have it here. I can leave it for download also. So I have an English manual, and you see this is really properly packaged. European plug, also nice. Doesn't look bad. Looks like a quality control. Wow, zoom in. So here it is, the power meter is the PM9901. I think it goes up to 600 volts. Well, I only need the 230, and it can go up to 20 amps. And they say it's switchable to 40 amps. But somehow I think it is pre-programmed somehow, or we need to open it to switch it over, because here it says maximal input current 20 amps. Huge knobs to connect the power. It looks like you can even fit in bananas also. And of course you can do your forks in here, which is the better connection. This is just to power the device itself. And yes, you can. And it's stuck, so that is possible, but I will not use that. I will use forks and then properly tighten it. I need some big forks, I can see, but that is okay. So I need to connect my source right here, and my load goes right here. And I'm not sure I need to connect those, because here is the amp meter, or this is already done, so we need to see. That is probably on the in the manual how to do this. There is an option for RS232 or RS485. I don't see it, but I can feel that you can add here a 9 pins connector, so probably it's just TTL to serial, so maybe I can just do that myself later. That would be interesting. It seems to have a hardware on-off switch. I like that too. And well, you can program alarms if it goes above a certain current, and you can, yeah. So let's get the manual. So, and the cool thing is I bought it around $100, which is actually cheap, because I know in the past they were around $1,000, and well, I have them now around 100. So they became a lot cheaper, and it doesn't look bad at all. I think Unity is a more professional looking one. They are around 200. So, but I was lucky I had some points, so in the end I think I pay around 60. And then I thought, okay, around 60, that is nice to replace my analog one. And let's see how the alarms work, how we need to connect it. And it even has feet to put it on your table, but I will make a more fixed position, and the numbers are big, so it will be perfect to see right there. And well, I just need to connect them, but mostly if I can probably just change the wires from that big meter there. Well, I'm pointing all the time, but you don't see, of course. Well, the alarm options seem nice, because you can set an alarm for a maximum current, but you can also set an alarm on the lower current. You can do the same for the power upper limit, power lower limit. So I can set my limit at 10 amps. If I start using more than 10 amps here, I have a problem. And maybe I can even set the alarm to 1,000 watts. Yeah, that is around 4 or 5 amps. While I'm looking at the safety instructions, do not open the device. But I don't see any warranty seal. And I'm actually wondering what is inside. And I didn't tell you, but this part is, it's metal. The back is plastic, the front is plastic, cheap looking plastic, but we also didn't pay too much. And the feet are removable, which could be handy because I don't have too much space there. No, proper frame. Okay, the feet are detachable, but I need to unscrew them. And I need to use a very little screwdriver because the screws are there. Okay. This is very small. This is just a little power supply for the whole circuit. Ah, here is my answer. The bridge is already made inside. Okay. And this is the little power detector. And wow, look at this. TXD, RXD, ground. So we could probably just connect it here, the serial connector. And yeah, I only need to, yeah, it comes directly from this IC. So if I know what it is, I can see if I need the TTL converter or not. But usually you need to. And then here I can put a 9-pin connector. And then I have serial output. Probably just a stream of information. Cool. Just quickly putting it on a microscope. This is the main chip where the +5 RxD TXD goes, ground. But it doesn't say anything. But I think it's always safe to assume that it is TTL to serial, and we can just do a little experiment with it. Because usually you have those CH340s, and this is probably just some memory or Yeah, I can't really put it well under the microscope. Yeah, and as I said, there is this alarm option, but to me it looks like here you can put, this will probably be a diode because this is your relay, and all those wires in the bottom just go here. And here is your output of the relay. But if I follow this line, just ignore the buzzer, you have here this little transistor. So I think that this already works. If we just put a little relay here, then we have the relay option that goes together with the alarm, I think. That just works. And here we have then our serial option that will also work. Okay, I did find my converters. And it is indeed 3H340. This is one of the latest generation, the G version. I do see one jumper in the bottom, and that is for switching it from 3.3 volts or 5 volts. And I think that is the TTL level, not the power level that it needs to be connected to, because it is powered from the USB. So I need to measure what the TTL levels are that come out of this device, and then I can just connect it to the USB and I have my serial output. Okay, that worked the trick with TTL to USB converter, so that is pretty cool. Let me show you what I did. Well, as I mentioned, you have here those RX, TX and ground connectors on the main board here. You need to cross that here with so the RXD you connect here to the TXD and vice versa, and then you only need the ground. This one I don't need extra pin. Don't mind the colors, it's just I had it set up like this, and this is connected to the USB, and when I started the software it just started to communicate. Okay, you should see both now. And I downloaded that software that you just install. I checked that my new USB device in the device manager, it is COM3, that one came extra. So if I open this software, I need to do first new file, then I say search for device, it is COM3, the PM99 series, and do the detection, and then you should see the communication start, and it does. Then I press the play button, and then I just say start, and now it will start logging information. And you see already here that the first logging is done. Yeah, we are not doing any power right now, so we don't see anything. But it is cool that it is actually trying to log it, and you can see on the USB device the little flashes of light, so it's really communicating. So that works. This option cost me now $2. I think it was not much more, these TTL to USB converters. This is how it is connected in the back, and I will remove the isolation to show you better. These forks I can use again. Sorry for the shaking, but I'm here on top of my entrance here, looking down, so this is kind of scary. So here, these forks I can use again. So there is the new meter. It looks quite cool. You can see here the voltage, the amps, how much power that is in total, the power factor. Well, I've got some old-fashioned transformers, but you can also switch that over to frequency. It's exactly 50 Hertz. And I can put the power factor, so maybe if I switch on here if I switch on here my soldering, It should add at least 50, and the power factor would change because it's another transformer. Here we go. And here it's off. That was about 50 watts exactly. I also have the USB connected, and well, I can, this is the voltage, but 230, it is just fluctuating a little bit, but it's maybe more interesting to see the current. So if I switch over to the current here, it's not that visible. Let's take the green one. The watts, the power curve. And now I switch on my solder iron. We at the 50 watts. Hup, here it goes. Then I switch it off again. So we can do with a lot of equipment, and you can see it go higher and higher and higher and higher. So I can do one. Switch power supply. Just a big peak. My other power supply. So some little devices, but you can slowly see it going up. Or maybe if I do the Marconi, they will see a big peak, I think. Up, here it goes. And then we can slowly switch off equipment anymore, and then it should go down little by little. So it is very sensitive. So that's a very nice extra that you can really see what is happening. If you want to monitor very precisely, I will switch the Marconi off. I don't need it, and immediately you see that the power that we use is going down, and all my lab goes through this. So that is really nice to monitor everything. So even the slightest, like if I switch on here, my little voltage meter from HP, it is very little, but you do see it. So it is really, really sensitive. If I do my frequency counter, it goes a little bit, but you do see it. Maybe if first I switch it off. And this is something I've to my 12 volts. Yeah, that is very slightly because it's a transformer. But everything is visible, even the slightest. Well, I'm still fighting a little bit with the alarm settings, because now I put it on silent, but it actually thinks that it is in an alarm, and I couldn't find out why. Because if I follow the manual and I just set my highest level to the highest possible and my lowest level to the lowest, so it should not be triggered. And also, if the current is triggered, then the current should be flashing, and nothing is flashing, but the alarm is just going. So this is like the default, and I don't see any value flashing, so that would actually mean that none of the parameters is triggered the alarm. But then why is it making a noise? So I will probably try to find out what it is, but I will remove the buzzer or make a switch until I find out what it is. Or it's just a bug, but it is not beeping when there is no load connected. So that is a little bit a problem for now. So that was the DCUU, the PM9901, the parameter meter, and I like the addition of the USB. We have a much better view. I have a great view here, everything what's happening with all my power. The analog meter was nice, but this is just more direct, and you see the sample is quite fast, so I like that. So thank you for watching, and I hope to see you next time.